In this video tutorial, we'll introduce the actual exploitation of the previously discovered vulnerabilities with Nessus and OpenVAS. For this particular activity, we'll focus on the Metasploitable Linux target. There will be a follow-up video for the Windows target. The expectation for the assignment is that the vulnerabilities for both targets are validated, specifically those that are high and medium. There will be a particular script and objectives that will be covered, and your task is to validate the vulnerabilities that you were introduced to in the video. So what we're going to do is we're going to use a Metasploit, the exploitation framework, to import results from Nmap, Nessus, and OpenVAS. We are going to match the imported vulnerabilities using the built-in functionality of Metasploit, specifically the Armitage graphical user interface, to match exploits and vulnerabilities. We'll then use the same interface to check if the target is susceptible to the publicly published exploit. And then if the target is susceptible, we're going to leverage the automation in Metasploit to establish communication channel with the target. As part of the post-exploitation activity, we're going to establish a communication with the target, pull the actual hashes for the passwords of the available user accounts, and then use John the Ripper, specifically Johnny GUI interface, to crack those passwords as part of the post-exploitation process. Please make sure to watch the requested videos that will help you complete the activity. Once you grab the different exploits, any validated exploit, you need to record a screenshot. And as you're grabbing the different screenshots, make sure that you're adding 2 columns to the table with results from the previous weeks. One column actually called exploit, and the other one is exploit success. So an example of an exploit, if you're finding a publicly available exploit from Metasploit, it will look like this: exploit Linux FTP. And then if the exploitation was successful, you can mark it as true or yes. So once you grab the screenshots of the validated exploits, you update the table, your assignment is complete. Again, make sure that you are working for completing the results for your Linux as well as Windows targets. What does that look like? Well, the first thing we need to do is make sure we start up our Kali VM. Please check your IP configuration. It will likely vary from the video tutorial. You need to make sure that you can communicate with both of your targets. The target in my example ends in .15, and you can see here that I'm getting requests and responses. What we need to do is, I'm not only going to be showing the process for the Linux target, you need to make sure that's done also for the Windows target. And again, the IP addresses in this video are different. You need to translate them to the IP addresses in your own environment. So once we make sure that we can talk from Kali to the target, the next step is to initiate the Metasploit database, msfdb init. So from the terminal, you're going to execute msfdb space init, hit enter, and this will initialize the database. The next thing we need to do is start the database. So you're going to hit start, hit enter, and this will execute. The following thing we need to do is either click on the Armitage icon on the left hand side, or type in Armitage from the terminal. Now, the one thing is, if for example, you start Armitage, you're going to have a command prompt like this. If you close it, Armitage goes away. So pay attention to that. So once Armitage is up, to wait to get it started is actually, I'm going to walk through this real quick. For Armitage to get started, we need to actually connect with the default configuration. Okay, So once I initiate Armitage, I'll be asked if I want to connect with the default address port, and I need to click yes. And then if I'm asked if I want to connect to the RPC service, I need to connect yes. So in here, there's no username and password, okay? Click connect. These are pre-configured. And then on the next screen for the RPC connection, click yes, you'd like to start the RPC service. So once you do that, and get away here from making sure I have enough resources for my VMs to respond. And I have things preloaded as the entire assignment takes some time. It may take you anywhere from maybe an hour to several hours to complete the assignment. And get out of this as well. Okay, so let's go into Armitage. So what Armitage is going to look like is like this. On the left hand side, you're going to find different modules. And I hope it didn't hang up. So the different modules on the left hand side. These modules are going to be broken down into 4 categories. We have the auxiliary, which are scanners. Scanners like VNC password, MySQL scanner, stuff like that. The exploit is the actual instruction on how to take advantage of a particular weakness, vulnerability. The payload is, the easiest way to understand is how we interact with the target. Is it through a phone in? Once the target is compromised, it will phone back to us? Or is it once we compromise a target, we connect directly to it? And the post-exploitation is once we've connected, we have a chance to upgrade our connection to add additional functionality like keylogger, or perhaps we'd like to go in and hide our presence, engage in persistence and more stealthy mode, migrate our session into a different process, and so on. Those are the post-exploitation. The post-exploitation activity that we will cover is tied into password cracking. So once we are here, the next thing we need to do is import actual results. Now for the import, what we need is actually to have pre-saved files. Okay, these pre-saved files are, you need the nmap XML file, and if you need to redo this, so that's in a previous assignment, essentially you need to run an nmap, and with this nmap it's going to look like this. You need to do nmap, aggressive scan, OA, output the results, and the results are going to look like that. Essentially you're going to find yourself with a number, 3 actually files, and the target.xml file is going to be the one we need to import. So the next file is the Nessus report with specifically .nessus extension, and the other report is the OpenVAS result with NBE. So what we will do then is come back here to Armitage, go into the host, import hosts. The import host is going to ask us for a file. Where do we save these files? And here they are. The target XML, click open. And what will happen is with the import process, it will take some time, but eventually with import, the results are going to show successful import. Okay. We need to do this for all 3 files individually. If you don't see anything but success, there's an error. Either the file or the file is empty, the results are not there. You got to see successful import. The next file is the Nessus, open, import, and then we have the OpenVAS NBE. Once these are imported, you can come into the console and type in help. And the help menu tells us what are the different available options for commands. So we see that one of them is vulnerabilities. Okay, and one of the things we can do is we can type in vulnerabilities, and we hit enter, And this spills out a list with all the different vulnerabilities we imported. Obviously, that's very hard to read. So what we need to do is we can actually narrow down the results for a specific host, particular service, and then get information for that service. One example is vulnerabilities. We want to narrow down the result to capital R, host. In my case, that's 10.10.10.115. And then the service is FTP. And then I would like to get some more information about that particular service. Okay, so now the results are not as much, but still, potentially quite a bit. So we're seeing this is where the command was executed. And then we're seeing the results. We see that there are different matches. Vulnerability detection result, vulnerability was detected, vendor fix, affected VSFTPD234. Okay, so we're seeing that we have such vulnerability for the FTP service. And how did I know to start from FTP? Well, I'm using Nmap. So the ports start from 1 through 65,535. Okay, so if I was to look into the Nmap results, which is my target XML, let's look into this example. So if I'm to look into the Nmap results, I start from the smallest port, which is FTP, and guess this, VSFTPD234. Okay, so I see that there's anonymous FTP. So obviously, what I can do here is I can, type in VSFTPD. So I can do it through the command line, or I can just come into the GUI here, VSFTPD, and I see that I have an exploit. Now, the other thing that I noticed from the Nmap result is I have anonymous FTP, and look at this, I have anonymous. So I have an auxiliary scanner to find out if this anonymous is there. So Nmap already detected it, and we know that from these results we have anonymous FTP. Okay, so the next thing we do is go into port 22. We see there is version OpenSSH 47P1. We're seeing if we have a matching exploit, and so on and so on. So we go through the Nmap scan one result at a time to validate. Why? My level of comfort with Nmap is very very good. Fairly confident in the results that Nmap is displaying based on my tuning and application of the function that Nmap provides. So what I'm going to do is I'm going to use Nmap as my marker. What I've done also is came in here and leveraged a tool to parse the results in more human readable format. If you're interested, ping out and I can show you how to do that. The tool is called Discover Script, and it includes a parser XML specifically for Nmap. It's a tool that I pre-built I preloaded in your environment. I can't take credit for building it. So it looks like this, and from here, if I'm going in and marking, I mark this port off, I mark the next one off, and I'm moving on to the next port. This way I can keep track of what is it that I validated. So I'm not going, running around in circles. So I started with this port. We went in. We're finding information. This is how we're searching. Now the next thing we need to do after we imported the results is let's go find attacks. So go to the attack menu, find attacks. Once we've done with this, we're going to launch Hail Mary. Hail Mary is essentially an automated script that goes in, finds what we've imported from the vulnerability scanner, matches it again to different exploits that are available, and launches to validate if they exist and the target is susceptible. If they are, Hail Mary will go in and open shells, and shells are command line connection to the actual remote system using whatever available protocol. A lot of the communication is plain text, so it can be detected. But if you're using an interpreter, it may be a little more difficult. So interpreter is the advanced interpreter for a Metasploit. Nowadays, it's very common and easy to detect by some modern endpoint protection. So let's say we went to attack Hail Mary. Hail Mary is going to go in and find some low-hanging fruits. And once the Hail Mary is complete, you're going to start seeing lightning strikes. Okay, this is where we are with these lightning strikes. And if you right-click on the target, you're going to see a number of shells. Now, the number of shells is going to vary based on the Nmap, OpenVAS, and Nessus reports that you imported. If you've done them to specifications, you're going to see what I'm seeing. If you don't see what I'm seeing, you need to restart your target and do it again. Rerun the vulnerability scan, rerun the exploitation. You may get one chance to exploit something. You may not get multiple. So we came here and we're finding these different shells. What does it mean? How are these related? What are those different shells? If we use the sessions command and we do -L, we can see that we have a list with a number of shells. Okay, so there's 4 through 10. They typically start in 1, but I've rerun the process one time and I had to disconnect to actually show the full picture here. So how can I find out more information about the different sessions? I use the sessions V. So now I'm going into each session number and I see that it's a shell and it's established through a PHP vulnerability and it's PHP CGI injection. So what you need to enter in your table with results in here is this: exploit multi HTTP PHP CGI arg injection. Okay, and what was this exploited through? Well, where's PHP running? Look at the service, HTTP. HTTP is what service? If I look into my Nmap result, which should be here, where is HTTP? Typically HTTP is port 80. See right there, HTTP. So I can list, therefore, the HTTP service on Apache for the Linux target. We see that PHP was a vulnerable version and it was exploited successfully. So mark in the exploit success column, yes or true. Okay, so the next thing we see here is we see session 5 is Unreal IRCD and it's IRC vulnerability, and that's Internet Relay Chat. The next one we see is Samba. This is a file share. So IRC, if we look into the port 7906, if I come back here to Nmap, 7906, we see the IRC is actually running on a couple of different ports. 7906 is not on a port that exists. Okay, so what we do in this case is, because it was the IRC service, we see that where is the IRC running? Well, is it Unreal IRCD? It looks like both are Unreal IRCD. Okay, so it was one of these ports. So I guess if I use the vulnerability in both, it should work on both of them. So it's port 667, and we've seen that there is an IRC vulnerability that was taken advantage of. So I would list this probably under both ports. We can validate that manually. All I need to do is type in Unreal IRCD, Unreal IRCD, and we see that there is a backdoor. Okay, so all I need to do is look at the default port 6667. What I need to do is, once I validate this once, I can change the port to the second port we have in Nmap, which is 6697, and then validate it this way. And if I come up with a new shell number, I know that it is working correctly. And it's another check I need to do and add to my table with results. So that's how we work through the list. Another thing I wanted to show you, you need to obviously go through and document each of these. So we're session 5, we got to go to 6. From 6 we go to 7. The Samba user map script, you're seeing that there's 2 of them. And Samba, where's Samba running? If we look into the table with results here, Samba is typically 445, 139. So look, Samba is running on these two. So because there are two shells, we exploited the same vulnerability to different versions. And we have two shells that are open, 139 and 445. And this is kind of the approach. You're going down the list and you're marking all of these ones. Now, the automated 2 is not going to catch everything, and we're going to touch this in a different tutorial.